Welcome to the Flame Challenge, and welcome to the Worldwide Assembly, where we're going to talk about the entries that are the finalist entries for the Flame Challenge in 2016. This is the 2016 edition of the Flame Challenge, and we've been doing this now. This is our 5th year, and we have had the participation this year of 23,000 kids around the world, 11-year-old kids, who are judging entries by well over 200 scientists. Let me tell you how the Flame Challenge got started. When I was 11 years old, I was very curious about a flame. I mean, a flame is so interesting. If you're really careful, you can put your finger through it. It's hot, but it's not solid. What is it? What's going on in there? So I really wondered what that was. And I asked the teacher, I said, what's happening in a flame? And she said one word. She said, oxidation. So now I had two things I didn't understand. They didn't understand the flame, and they didn't understand the word oxidation. And I continued to wonder about that. And many years later, decades later, when I was writing an article for a science magazine about communicating science, I realized that I had a really nice personal story to tell about how I had not understood somebody who was trying to communicate science to me. And I thought, wouldn't this make an interesting contest to see if scientists can explain what a flame is to an 11-year-old, so the 11-year-old not only gets it, but is kind of delighted by the explanation. Because you want people hearing about science for the first time to be delighted, so they want to hear more. So we started a contest, and we had scientists joining the contest from all over the world. And each year we've changed what the question is, guided by students with their own wish to get a question answered. So this year, the question is, what is sound? And we've had 26,000 kids from around the world judging the contest, because the wonderful thing about this Flame Challenge is that the winners are judged by real 11-year-olds, which makes it really tough for the scientists, because it's not somebody thinking, what would an 11-year-old like? It's 11-year-olds saying what they like, and whether it's informative enough for them, whether it engages them enough. So listen to where our 26,000 kids come from. Australia, Canada, China, England, Germany, India, Ireland, the Netherlands, New Zealand, Pakistan, the Sultanate of Oman, Thailand, United Arab Emirates, United States, Italy, and Germany, all around the world. And the scientists, 220 of them, come from 18 different countries: Australia, Canada, Costa Rica, Egypt, Finland, Germany, India, Indonesia, Ireland, Japan, New Zealand, Portugal, Romania, South Africa, Spain, Syria, the United Kingdom, and the United States. So welcome to all our kids around the world. Welcome to the scientists, and thank you to the scientists who have joined this contest. They've really put themselves out on the line to see if they can communicate what is sound to real 11-year-olds. Let's meet the kids who have joined us from around the world in today's webcast. We have 7 schools going far and wide across the globe. And let's say hello to them now. In Arizona, the Knox Gifted Academy. Hi, kids. Glad to see you. How are you? In Illinois, the Roosevelt Middle School. Hiya. Great. In India, the American School of Bombay. Great. We got good sound there. That's good. In California, the Los Alamitos Elementary School. Great. And in England, Southampton England, the Townhill Junior School. There you are. Great. Good to see you. In Connecticut, the Beecher Road School. Can you hear us? In Connecticut? There they are. Hiya, kids. Great. And in Vermont, the J.J. Flynn Elementary School. Great. Good to see you. This is terrific. So, let's start off with our first entry. Let me see where the first, here it is. Before we get any further, I want to thank the folks who have helped us put this all together. The wonderful organizations, science institutions that have helped sponsor the Flame Challenge. The American Chemical Society, the American Chemical Society, a huge, wonderful organization of chemists, and the American Association for the Advancement of Science, another huge institution that does incredible work in this country, not the least of which is sponsoring the Flame Challenge. So, okay, let's get to our first. What we're going to do is we're going to show you an entry, just part of a written entry. I'll read it while you look at it on the screen. If you throw a pebble into a puddle, what happens? The pebble causes a splash which pushes the water molecules away, and they crash into each other, and little waves are formed which move away from the pebble. The sounds you hear are waves created by vibrations in the air around you which reach you like the waves in the puddle. So that's just to remind the kids who are going to discuss this today of the entry, which they've been talking about with their teacher now for some time. And they've been going over this entry and a few other entries, comparing them, seeing which ones they like best. And that's how we got these finalists. Then in a few days, these finalists will be boiled down to the winner in the video category and in the written category. So today we're going to have a little discussion. We'll start off with with Southampton, England, the Townhill Junior School. Where are you? Hi, kids. Who's up first? Hi. Who can come up first? Thank you. What did you think of this entry?
Yeah, I liked it.
What about it did you like?
I liked when we watched all the videos and
Did you find it clear?
yeah,
And did you feel what made you think it was better than any other entry you saw? Was it
because
Oh, your sound dropped out. Okay. Okay, let's move on. Let's go to, thank you for that. Let's go to Mumbai, the American School of Bombay. Can you guys hear me? Can somebody come up to the microphone and talk? Hello.
Hi, my name is Shira.
Hi, who are you?
Hi, my name is Shira.
How do you do?
Shira.
How do you do,
Good.
sir? Tell me, what was your impression when you saw this entry?
So in Passage 108, we thought it was really cool how the scientists compared.
You know what? Go a little bit to
We
your
thought it was
right.
really cool how
Wait a second.
the scientists.
Wait a minute. Move a little bit to your right. I can't see you. There, that's better. So what did you think about what the scientists did?
So in Passage 108, we thought it was really cool how the scientists compared sound to nature, like birds, cats, and the throwing of a pebble. But we also found it middle interest because there were too many facts.
Too many facts. That's interesting. Okay, that's interesting. What did you think?
so we learned anything new, so we weren't engaged.
I'm sorry, say that again?
So we didn't learn anything new, so we weren't engaged.
Oh, you weren't
We didn't
engaged. That's
engage.
interesting. What kept you from being engaged, do you think? Were there too many facts, or it wasn't told to you in a way that was fun, or what? What do you think?
Well, we thought that there were too many facts, and it didn't really make us feel comforted and like the reader was actually talking to us.
Ah, that's very interesting. That the writer wasn't actually speaking to you. It was more formal, more to a wide audience, not to you personally. You feel? Okay, that's really great. That's very interesting. Let's go to the Knox Gifted Academy in Arizona. Where's Arizona? There you are. Hi, Arizona.
Hello,
Hello.
I'm Paul.
Paul, hi. You and I have a connection, don't we, Paul?
Yes.
Yeah, because is your sister Lily?
Yes.
And I met Lily about 15 years ago. Tell a little bit about what that was. What happened when I met her?
So, My sister's deaf, and you were there when she first heard for the first time.
So I think I was there for her operation. Was I in the operating room?
Uh,
Okay, well, neither one of us remembers it too clearly. It was 15 years ago. But how's Lily doing now? Is the cochlear implant that was implanted in her during that operation, is that working all right now still?
Yep.
Oh, that's
Still
great.
working.
That's
She
great.
can hear clearly. Great.
Oh, that's great. That must have made a big difference in her life.
Oh, yeah.
How old was she when she got the implant, do you know?
I think she was 2.
Oh, really? Oh, that's great. That's so important at that age. So it's interesting. That just happens to coincide with what we're talking about in the Flame Challenge this year, because it's all about sound. And as far as I understand it, the cochlear implant is a way to take the part of the hairs in the ear that pick up the sound through the vibrations in the air. And when those hairs have been damaged, the cochlear implant can substitute for them, as far as I understand it. But you're hearing in these entries that the scientists are sending you, you're hearing all about the hairs in the ear. You're hearing all about vibrations in the air and that kind of thing. Tell me, Paul, what did you think of this entry that I just read you a little bit of?
I liked it. I thought it was very clear and it had good vocabulary that I could understand.
And it didn't bother you? It didn't seem to you that the writer was not being clear, not speaking to you personally? You felt okay about the facts, I guess, huh?
Could you repeat that?
That it didn't seem like there were too many facts to you?
Yeah, I thought they could add more facts.
More facts.
About it.
That's
Yeah.
interesting. That's great. That's one of the things I love about the Worldwide Assembly is we get so many different ideas, different people responding in different ways, and if we can only pin down what it is that was good about what was good and what didn't work about what didn't work, it really can be helpful to scientists as they communicate to a broad range of people. Paul, thanks. It was fun talking with you. Say hello to Lily for me, okay?
Okay.
Okay,
Thank you.
Let's go to Illinois. Start coming up to the microphone. What's the name of the school in Illinois? Let me see. Roosevelt Middle School in Illinois, in River Forest. Where are you? There you are. Hi, how are you? So what did you think of that entry?
I thought that it did a really good job of explaining in a simple way. And so, yeah, I thought it did a pretty good job.
So you felt it was easy to understand?
Yeah, it was easy to understand, and it used a good word choice. And I liked also how it talked about the pebble, when it used a real example that most of us have done.
Right. So there was an example from everyday life, huh? That's something you recognized. Yeah, that's a good point. Thank you. That's very helpful. Thank you very much. Talk to you later. Should we go on to the next? Let's go. Let's see. What's next here? Video entry number 701. This is a video entry, and the full entry is much longer than this. We're just playing a clip of it so the kids can refresh their memories on what the video was they saw. Let's play entry number 701.
Imagine a chain of clones, mostly staying in one place, but passing wiggle energy from one clone to the next. It's kind of what air is doing. But it's not sound yet. It has to get inside your ear for that. It goes into your ear and wiggles your eardrum, which wiggles little bones in your ear, the smallest bones in the human body. The wiggling bones move around a liquid that wiggles tiny strings, all just to let your brain know there's a wiggle in the air. There's a lot of wiggling going on here.
There was a lot of wiggling going. Let's go to Woodbridge, Connecticut, the Beecher Road School. Come on up to the microphone. Hi, there you are. Hi, how are you? So what did you think of that video when you saw it?
Well, I really liked how in the beginning, how they used the clone's head exploding to express how interesting sound is and to help keep us engaged. And I like how they used the chain of clones to help express how sound moves.
There were pretty strong graphics in that, pretty good illustrations of how the inner ear worked, weren't there? And did you feel it was funny, humorous? And that was okay with you? You didn't mind the humor?
What?
You didn't mind the humor. Some kids find humor if there's a lot of humor, they want more facts. But here you felt that there was a good combination, maybe, of both facts and humor?
Well, I liked how the humor helped to keep you engaged, and they did give you a lot of facts, and I don't really think it took away from it.
Okay, that's great. That's very helpful. Thank you very much. Let's go to Burlington, Vermont, the J.J. Flynn Elementary School. Hi.
Hello.
What'd you think? What'd you think of that video?
I thought it was funny, but also at the same time, he was teaching us about sound, how it works.
Did you I'm interested in something. Did you learn from an individual video about sound enough to understand, to feel you understood it, or did you need to hear it from 3 or 4 different videos?
Just one time.
One time. That's
Just
interesting.
One. Yeah.
Yeah. And when you compared this video to the others that you saw, you felt that this was complete. It wasn't missing what other videos supplied you with?
No.
Okay. Very good. Thank you. Thanks very much. Let's go to another school. Let's go to San Jose. Come on up to the microphone at the Los Alamitos Elementary School.
Oh, hi. Okay.
Hi.
So, I think entry number 701 from Michigan was the best video because it explained what is sound through humor, and which made me to understand it better and easier. Also explained like how molecules push together and to keep that same pattern. And since our class learned about molecules in our science textbook, it made us more understand it easier. So that was a good example.
Oh, that's good. So it tied in with what you were already learning, huh?
Yes.
Yeah, that's
exactly.
great. What did you think?
I thought they used the word wiggle a lot, and I thought that was a little bit distracting.
Okay. Well, did it bother you when he actually wiggled? Or were you okay with that?
It was a little bit weird. I think that was a little bit distracting too.
Well, let me hear from your partner there. Did you find it fun and amusing when he did the wiggling?
Yes, I did.
Yeah, it's so interesting. You know, sometimes humor lands on some people really well and on other people not so well. Let's hear from your partner again. What you had more to tell me, right?
So instead of using the word wiggle, maybe vibrations would be a good substitute. But they also knew their audience pretty well, so it was kind of easy to understand. It wasn't like confusing or anything like that.
That's great. Thanks so much. Let's move on. Let's go to Illinois, River Forest. Come on up to the microphone at the Roosevelt Middle School. Hi.
Hi.
Are you near the microphone?
Yeah. Oh, sweet. I thought this particular entry was the best because it made it simpler for kids to understand. Like, instead of saying long words that kids wouldn't understand, like vibrations, it might be a little hard to remember. They said things like wiggle energy, which is really easy to remember. I also like how they got the viewer involved. Like he told them to wiggle their like this.
So am I hearing you correctly? Are you saying you like the use of the word wiggle because it's easier to remember than, say, vibration? Like vibration is too tough a word. Can you hear me okay?
It's a little like
broken
bouncy.
up. Okay. Okay. I think I know what you said, so I won't press you on it. Thank you so much. That's very helpful. One more. Let's go to Southampton, England, to the Townhill Junior School. Where's England? Come on up. Come on up to the microphone. Hi.
I think that it was really easy to understand. And
Did you
fun.
and did you feel you learned a lot about what sound is from this one video?
Yeah, because I bet anyone under the age that I am could be able to understand it as well.
Ah, good. So do you think after you saw this in school, were you able to go home and tell your mom and dad what sound is? Were you able to really get a good grasp of it and explain it to your family?
Yeah.
Well, that's great. Good to hear that. Thank you. Let's go to our next entry. This is a written entry, number 156. And just a little bit of it. Music is really amazing because when the tiny hairs vibrate back and forth to music, electricity reaches the brain's hearing areas. So sounds are vibrations that make you hear and might also make you feel like tapping your feet, dancing, crying, or even jumping for joy. Pretty amazing what tiny hairs vibrating inside the ear can do. So let's have a reaction to that from Connecticut, Woodbridge, Connecticut, Beecher Road School. Hi.
Hi.
What'd you think of that entry?
I thought that it was a really good entry because it explained really well about, like, imagine if you were really tiny and you went inside the ear to see what it was like. So I thought that was pretty good because it explained more.
Oh, that's great. That's interesting. It gave you a chance to use your imagination, and actually you could get inside the ear so you could explore it, not just in words, but you could actually, in a way, in your imagination, see things inside the ear, I guess.
Could you please repeat that?
I can't remember it. I'm saying that you could, it sounds like you're saying that in your imagination, the entry allowed you to actually get inside the ear and see for yourself what was going on.
Yeah, I imagined that I was a really, really tiny person. I could just walk down, like, in a weird hairy ear. And so, yeah.
That's great. That's great. It'd be fun to get inside a hairy ear. Let's go to Burlington, Vermont, get a reaction from the J.J. Flynn Elementary School. Come on up to the mic. Hi. What did you think of that entry?
I liked it, but they could have explained more about how we perceive sound.
Ah, this is interesting. So you felt that the idea of sound getting to your ear might have been good enough, but you wanted to know about how it gets from your ear into your brain and how your brain processes it. Is that what you're saying?
Yeah.
So did you find that other entries talked about about that part of hearing better?
Mostly.
Yeah. Okay. Well, that's an interesting comment. Thank you very much. Let's go to San Jose. Come on up to the microphone at the Los Alamitos Elementary School in California. Hi.
Hi. I thought this entry, the author did a really good job knowing the audience. Like, for example, the author used easy to understand vocabulary, like vibration and electrical signals.
Uh-huh.
And I also think the author could have said, instead of saying, a drummer bangs on a bass drum, Sam standing nearby hears, boom. Maybe the author could start the entry with, boom, a drummer bangs on a bass drum. That
Okay.
might...
Wait, go back a little bit. Just tell me that last part again. You thought the author could have done what?
The author could have maybe added a hook and started the entry with boom.
So you thought the author could have got your attention better if he started with something snappy like boom, huh? Is that right?
I really liked it because I thought it explained what is sound really well. And I liked how he did the example of, like, Sam and how Sam heard the vibration of the drum when it was banged.
Right. So did you feel that it benefited from being very specific and personal, that he used a person's name and described a person hearing the drum, that it wasn't just technical terms, it was more personal? Did that make a good impression on you?
I think that was a good idea because then it's just like showing that like what happens inside one person, like in their ear, instead of like a big thing to show everything.
Right, that's great. That's a very good reaction. Thanks for sharing that with us. Let's go to River Forest in Illinois, the Roosevelt Middle School. Come on up to the mic. Where are you? There you are. Hi, how are you? What did you think about that?
I thought this entry was spectacular because it describes how loud sound vibrations travel back and forth, creating pressure waves. And this entry was definitely unique to me because instead of just giving me information, it gave me examples.
Okay, your sound was breaking up a little. You said, go back and just tell me that part about it wasn't just giving you information, it was doing what?
I thought this entry was definitely unique to me because instead of just giving me information, it gave me examples.
Ah, examples. Yeah, that's so good. I find that all the time when I'm trying to figure out something that's complicated. If the person explaining it to me gives me examples and explains it to me in 2 or 3 different ways, then I get it from different angles, and it really helps. Examples help a lot. That's a very good contribution. Thanks very much for that. I appreciate that. Let's go to India. Come on up to the microphone in Mumbai, the American School of Bombay. Where are you? Hi, come on up to the mic. Who has the mic? Everybody's deferring to everybody else. Here comes somebody. Great. Come on up. Come on. Yeah, be brave. Come to the microphone. Can you hear us? Can you hear us in Bombay?
Oh, okay.
Mumbai? Yeah, good. What did you think of that entry?
So we really liked it because it engaged us with the micro story at the beginning that the other ones didn't really do, and that really got us to think about how we would think of sound and then relating it to the information.
So what is it, do you think, that engaged you? What especially engaged you? Can you remember?
Well, having the start where it said boom and then how Sam heard the drum, it sort of, pulled us in to learn about like why Sam heard the drum sound that way. I mean, all of us have heard drums before, but like how it's worked, none of us have really, known about.
Yes, very good. So it did start with boom. I misunderstood, and I forgot that entry, the beginning of that entry before, so I apologize for that. That's great. It does get your attention when it starts with that sound, and you hear a sound. So it's in your mind you hear a sound in your imagination. So that's a good way to start. Thanks so much. Let's go on to our next entry. That was written entry number 156. We're up to number 740, a video entry coming from California, right? The scientist is in California. Here's number 740.
Okay, so this is a tuning fork. When I hit it, 2 things happened. First, it starts vibrating. It's difficult to see, so I'll dip it in water to prove it to you. Second, we hear a sound. I'll hold it up to my mic so you can hear. So already we know that vibrating objects generate sound. Okay, now let's do a simple experiment that almost looks like a magic trick. I've set up 2 tuning forks and I've hung a ping pong ball from a string next to one of them. All I'm going to do is hit this tuning fork over here. Check it out, this tuning fork starts vibrating and it's bouncing the ball. But how? Well, clearly something has to be traveling from this tuning fork to that one, and that something is a sound wave.
Okay, let's get a reaction to that from Southampton, England, the Townhill Junior School. Somebody come on up to the microphone. Where are you? Hi, good to see you. What'd you think of that?
We liked it because we thought that it allowed us to give us the imagination of going on that journey with the sound waves.
I must say, I was amazed. Go ahead.
It was easy for kids under 10 to understand all of the facts because he has put it in difficult words for us.
Yeah, were you kind of amazed when the ping pong ball started bouncing around just because a tuning fork a foot or two away was vibrating? I thought that was kind of amazing.
Yeah.
I had never seen anything like that. It's really fun.
Yes.
Yeah, isn't it really interesting what you can do with sound? You can make sound visible like that with the ping pong ball suddenly becoming a visual object moving in tune to the vibrating tuning forks. I thought that was fascinating. Well, thanks for that. I didn't mean to interrupt you. Go ahead. Go back and say it again.
It's amazing what sound can do.
It is, isn't it? I agree with you. Great to talk to you. Thank you. Let's go to Arizona. Come on up to the microphone at the Knox Gifted Academy. Hi, what'd you think of that?
First of all, I thought the experiment was really interesting and really captured my attention. But I think that the part with like the feather duster was a little confusing when he was sort of inside the ear and he got hit with the feather duster. But I have a kind of a general question about sound. Is it possible for the 3 small bones in your ear to break? And if so, what happens to your hearing?
Boy, I don't know. You know what we have to do? This is a really good question. I'm not qualified to answer that, but what we should do is get an expert to answer it, and we'll put the answer up on our website. Thanks for posing that question. We'll get your name and we'll put that up on the website along with your question, and we'll get an expert to answer it. Thanks so much. That'll be useful to a lot of kids around the world when they read the answer. And to me too, because I don't know the answer. Let's go to Woodbridge in Connecticut to the Beecher Road School. Somebody come on up to the mic. Thanks. Hi.
Hi.
What'd you think?
Well, I thought the experiments that he did were really cool, like how he showed the vibrating tuning fork and how it made the water squirt everywhere. That was good.
Yeah, it was very vivid, wasn't it? Do you have any complaints about it? Are there some parts of it you wish were a little better? I mean, we would want to be helpful to the scientists coming up with these entries. Did you have any suggestions about parts that could be better in your mind?
Well, I thought his whole video was really, I don't think it needed any improvements personally.
Great, great. That's terrific. Good to hear. Thank you. Let's go to San Jose. Come on up to the microphone at the Los Alamitos Elementary School in California. Hi. How you doing? What'd you think of that?
I thought that it was good because it connected to both the audience's head and their heart by telling them that sound was so important that they were going to use it to introduce ourselves to alien life.
Good, good, good. How about your partner? What did your partner think?
I thought it was very good, and I liked how he did all the examples, like the tuning fork and the ping pong ball, and how like it was vibrating and he dipped it in water. I thought those were really good examples.
Yeah, they were very vivid examples of what he was talking about. He didn't just say it vibrates. You really saw the vibration have an effect. What did you feel about his tone? Did you feel he was talking to you or giving a sort of a lecture to everybody? Did you feel it was personal enough?
Yeah, I thought it was like he was talking to his audience really well. And that he was doing a good job. I thought he was doing a good job.
That's great.
With talking to his audience.
Good, great. Thank you very much. Let's go to Illinois. Come on up to the mic at the Roosevelt Middle School. Hi, how are you?
Good.
good. How are you?
I'm very good. I'm having fun talking to all of you. What did you think of that video?
Well, I thought it was the best entry that there was because it used hands-on experiments, and it made me wonder about other things about how my instrument, which is the tuba, made sound, even though it didn't have strings.
Oh, that's great. So did you learn something about your tuba from watching this video?
Indeed, I did.
Oh, what can you tell me a little bit about that?
Well, I found out that when the airwaves moved through my mouthpiece, it went all the way through my tuba and out the other end.
That's great. That's great. What other thoughts do you have about the video?
It made sense quickly, but not very, very quickly. Like, it got to the point fast, but not as fast as just saying the answer right away.
So you felt it was good that it got to the points quickly. Is that what you're saying?
Yes.
Or was it wasn't too fast for you?
Yes.
Okay. Well, that's great. Thank you. That was a very, very good good contribution you made. We really appreciate it. Thank you. Let's go to our next entry. That was number 740. So we'll go to the written entry, number 259. We're just doing a little bit of this to revive everybody's memory. So I lost the signal. Do you have? Okay, here it is. When you speak, your voice box vibrates. Try it now. Talk to your friend and feel it on your neck. In fact, it causes hundreds of vibrations at the same time, some fast, some slow. They travel through the air and into your ear. But imagine if you could hear each vibration individually. You'd never make sense of them all. So instead, your brain makes sense of them or something. Your brain looks for patterns. My screen keeps popping out, so that's why I got a little confused there. Let's go to Burlington, Vermont. Come on up to the mic. J.J. Flynn Elementary School. Let's see what you thought of that written entry.
I think it was really good at explaining how there's. I thought it was really good at explaining how there's a lot of vibrations that cause sound and how the vibrations help you hear.
Good. Do you have any thoughts about how you think it could be better?
I think maybe like more about what happens once the vibrations like reach your ear, like so you would you understand like the signals, how they get to your brain and what it does.
Right. So this is interesting. You're the second person to say that you'd like to have heard more about how the brain perceives the sound, how it takes the vibrations and turns it into what we think of as a sound. That's very interesting. And what interests me about that is that you folks are at or very near 11. And as I was when I was a kid, when I was 11, I really wanted to know what was really happening inside. And when you ask questions about what's going on in the brain that enables me to perceive that sound, you're asking for something pretty complicated. And I think even though you want it to be engaging, you want to know the real story. And I think that's very, very important. It's very enlightening for those of us who are trying to communicate to a whole range of people, especially to 11-year-olds. Thanks so much for your response. Let's go to Chandler, Arizona, the Knox Gifted Academy. Where are we? Oh, there we are. Hi, what'd you think of that?
Well, I didn't really think it started off with a strong introduction, because usually I prefer that most introductions start off with a question.
Oh, that's interesting. So this introduction, what's good about starting with a question? Why do you like that?
Well, I kind of prefer it because you know that there's going to be a story that you're going to find out later on when it's written.
So it's very interesting. So I'm trying to find out, because it's a very common way to start an introduction with a question, and I find it very helpful to do that when I talk to people. And I'm trying to see what is good about it for you, for the listener. Do you find it more engaging? Do you start thinking about it? Do you start trying to answer the question in your head, and therefore you're more focused on what's coming next?
Yes.
Ah. And what happens when the person does not start the introduction with a question? Do you just feel like you're what's your feeling then?
I could still be engaged in it, but it just doesn't make me feel interested in the way if it did start off with a question.
That's really interesting. I'm glad you brought that up. Thank you. It confirms something that I feel about communicating too, and I'm very glad to hear it come out of you. Let's go back to India, to the American School of Bombay in Mumbai. Somebody there? Come on up to the mic. Great. What did you think of that?
I find that it's very appropriate for our age because of how it uses an example. Like when you talk about it as pixels, it seems a lot less complicated because a pixel is something that we work with every day. We might know a lot more about it than we do sound. So putting it into example makes it much easier for us to understand.
Great. That's so interesting. Go ahead.
Also, I think he used good vocabulary because...
Are you still there? Okay. It's very interesting that you bring up pixels being a part of your everyday life. When I was 11, I had never heard the word pixel. We didn't have pixels as part of our daily lives. And now, vibration, which was more familiar to me then than a pixel, you feel better if it were translated into something you're familiar with, like a pixel. So we have to be aware of how language keeps changing and how kids use language if we're going to be appealing to them, I guess. That's very helpful. I appreciate it. Thank you. Let's go back to Illinois and see what you think about that. What do you think in Illinois?
I think that, well, some people brought up that it said some things about seeing in pixels, and I think that it explained the similarity between seeing and hearing very well, and it also stayed on topic with hearing, even though it did explain seeing a little bit. It also said how it'll group things, like if you're listening to an orchestra, it said how it'll group the different instruments a little bit.
Right, so that was an easy way for you to understand how the brain picked out patterns in the vibrations.
Yeah.
Yeah, it's an interesting and it could be a difficult concept to get, but it's great that you felt that he got through to you with that image.
Yeah.
Okay, great. Thank you very much. Let's move on to the next. Let's see, what's next now? We did. Have we done them all?
Nope. Last one. Video 742.
Video 742. Wait a minute, don't go anywhere. I'm still trying to find it. Wait 1 second. 742. Oh, 742. The video entry 742. Why didn't you say so? All right. Okay, this was from a scientist in Michigan. Let's play 742.
The Rubens tube helps us to connect all of these ideas about sound: pitch, frequency, and wavelength. We see that a high pitch causes short wavelengths, and of course a high pitch is high frequency. We also see that a low pitch causes a long wavelength, and that's due to a low frequency. Now I think it's really fun to send a bunch of different frequencies through the Rubens tube. Let's try that. Whoa, wasn't that cool?
So what did we think in San Jose? Somebody come to the microphone at the Los Alamitos Elementary School. What'd you think? Hi.
Well,
Hi. Well, I thought that he explained sound very well, and I like how he used all the examples, like the Rubens tube, and you guys didn't show it, but the long tube and the short tube that he sent the air length through.
Right.
And well, when he used big words that I didn't know or understand, he explained them and he told us what they mean.
That's great. That's a good response. Thanks. What did you find? What did your partner, what did you think?
I thought that when the big words popped up, I think they're distracting because it blocked what was in the background, so I didn't really know what was happening when the words popped up.
Did you find the Rubens tube easy to follow? I mean, it's an amazing thing to see. Did you know what was happening in the Rubens tube?
I'm pretty sure that the sound wavelengths were moving so that it showed up in the tube, which the gas, which controlled the gas.
Right. So those vibrations were being visualized by the gas in the tube and the flame. So it's interesting. We went back to the flame challenge with this sound experiment. That's great. Thanks very much, both of you. Let's go to England. Southampton, England, Townhill Junior School. Hi, what'd you think of that?
We liked the Rubens tube and what happened when he put in the sound frequencies. When it went like high and low, and it kind of made it was a nice sound.
Did you find anything that you would like to have seen more of, or something that you didn't quite understand that you wish you had a better explanation of? I'm just trying to be helpful.
More of the how like high and low you can go with the Rubens tube, because I'd like to see what you could do with it.
It would probably be fun to be by that scientist's side and play around with that Rubens tube. You could probably learn a lot by experimenting with it. Let me hear from your partner. What did you think?
I found it a little bit confusing because I'm only 9, but I think it would 11-year-olds would understand it more than me.
What can you tell me what you found confusing, and maybe tell me a little bit why it was confusing? Can you remember one part that was not so clear to you?
The part with when he talked about the Rubens tube, I understood that, but some of the other things I found quite complicated.
Okay. So you think that maybe he should have taken the time to explain them a little bit more, what was happening and why it was happening? Would that have helped, do you think?
Yeah.
Okay, that's going to be helpful. Thank you. Let's go back to Mumbai, to the American School of Bombay. Come on up to the mic. Hi.
Hello.
What are your thoughts about that video?
Well, we thought it had very cool experiments, and the keywords were displayed, so it helped us understand. And so the Rubens tube was used in all 3 videos, but especially this video, it was used very differently in a good way.
Right. Okay.
And they also
Go ahead.
They also had high quality, like animation kind of, and they also broke up the explanation into like frequencies and vibrations and other stuff.
Right. So you feel clear about what frequencies are and what vibrations are and that kind of thing, and this video made that clear to you?
Yes.
Great. How about your partner there? Did I already hear from you?
Yeah.
I'm sorry. Okay, I couldn't tell who was talking from here. Thank you. Thanks very much. Let's go to Connecticut. Come on up to the mic at Beecher Road School. Hi, what'd you think of that video?
I thought his experiments were pretty good. It helped me understand more about the concept of sound and how it works.
What did you?
What?
Did you think there was something about it in particular that you liked better than other videos?
Experiments and like the Rubens tube.
So he made it visual for you. He really showed you with those experiments what he was talking about. Is that right?
I didn't think he didn't explain how we hear the sound. So if he could explain more about that, that'd be great.
Right. So it sounds like another example of asking for more of an explanation about how we perceive sound, about what happens between the ear and the brain. Is that what you wish you had more of? Yeah, good. Okay, that's very interesting. I'm very interested in the fact that that's probably the most complicated part of what sound is, and you want to know more about that complicated thing. And I'm glad to hear that. How about your partner there? What did you think?
I thought it was pretty good because it was good how he did really good explaining things.
Great. How about now somebody who's a third person there? Go ahead.
The experiments because he really showed about the frequencies and how high and low a sound could be with the different lengths of like the tubes.
So he made it clear with those different tubes. When you see the whole video, you see those tubes. Anybody watching this who hasn't seen the whole video wouldn't quite know what you mean. But I guess we can see all of these videos in their full length on the Flame Challenge website, and also the written entries in their full length. And I think it's fun for people to go to them and to pick out what you think, in case you're not voting, pick out what you think you would like to be the winner, because in the next few days, real 11-year-olds around the world are going to be picking the winner from among all of these entries. Let's have one more visit to River Forest, Illinois, the Roosevelt Middle School. Hi.
Hi.
What did you think of that?
I thought it was really cool. I liked how they used the fire as the sound waves.
I'm sorry, would you say that again? I didn't get it. The
I
fire?
liked how they used the fire as the sound waves.
The what? The fire and how the sound waves affected the fire in the Rubens tube. You're right. Yeah, I thought that was very interesting too. It's amazing to see it visualized like that, because we're so used to thinking of sound as only something we hear, and now you can see that it can also be made visible with this tube. Any other impressions of that video?
Do you have any questions? No. I mean, I thought it could be a little bit more clear.
You wish it were a little more clear about what?
Because of the words that they use, I thought that they could have explained what they were talking about a little more.
Okay, that's good. So it's always a challenge, you know, to be able to get deeply into something complicated like this, and yet keep us with you and make sure we are continuing to understand what's being explained. That's why we started this contest, to help scientists see what it's like to try to get inside the mind of an 11-year-old with respect and be engaging, but not be too silly, and just enough to be engaging, but to keep track of what they're understanding as we tell them. So your reaction was a very good one, asking for that. I want to thank you, and I want to thank all our kids for coming together in this worldwide assembly. I want to thank we couldn't have done this without the help of the American Association for the Advancement of Science and the American Chemical Society. Now don't forget, on May 4th, that's the deadline for the final vote. I'm really looking forward to seeing which written entry and which video entry you choose as the winner. It's been very much fun for me talking with you. You came up with such good explanations of how you thought the explanations you were judging were good or could have been better. It was very helpful, I think, to anybody watching. So until next year, when I hope we all get together again, and I hope that you'll tell your friends if you had a good time so that they can join in the contest next year. And teachers, if you think it was a good experience for your students, please tell your friends, and maybe we'll get even more classrooms next year We'd love to expand this indefinitely. So meanwhile, so long for the Flame Challenge.